All right, sorry about that. Had somebody at the house here that was needing something. So anyway, we'll pick back up on this, finish this out, kind of a part two thing. So let me go back here. All right, so as I was saying, I don't remember exactly where we left off, but um, the number of elbows you have, the number of feet of run you have, obviously is going to make a big difference. Once you go up to a larger size, you got to get rid of more combustion gas. You may have to go to 3-inch pipe anyway. This one doesn't really go into like, when you could run one or the other. So, like I said, this chart's a little bit generic, but you're going to refer to the manufacturer specs on that. So there's no like, for sure answer. It's going to really come down to what the manufacturer says. Some furnaces will push it a pretty good ways, and others won't. So you got to make sure you check that. Concentric vent terminations. Um, Basically, what these are doing is they're set up in a way that one one vent termination, one hole, one opening, one pipe could supply combustion air to the furnace and also supply vent outside from the furnace. So you're getting rid of your flue gas, and you're also bringing in combustion gas. So it's basically kind of a double wall pipe. I don't have any more of a breakdown here, but you can see here you've got combustion air that comes in around the outside, and then on the inside, the center, you've got your vent. So your flue gas is coming down the middle, venting straight out. It's also bigger, but then it steps down smaller to where it increases your velocity at the end. And then your combustion gas for air intake is coming in around the side, going around the outside of this, and going back through your 2-inch or whatever size pipe you got going back to your furnace. So it allows you to be able to pull both through one hole. That may be good from an installation standpoint. So that comes into play, or you see that's what they're doing. All right, so category vent terminations. That's a term you need to get used to hearing or to referring to as termination. So, like on your journeyman exam, it will say something like maybe how far from a window can you um, can you put a vent for a 100,000 BTU furnace or something. Um, it may not use the word vent termination or how far does it terminate. But that's one way that you can look that up is when you're looking up ventilation in the back of your code books. It may say ventilation, and then below it, it has subcategories, and one of those may be terminations. Terminations is like where it ends. So when you run something out, or you even on your inlets where you started, I guess, how far from the top of the roof line does it have to be? How far from the other from the inlet does it have to be? What direction does it have to face? All that stuff comes into play. So just an example, um, a rooftop termination, if you're going through a roof and you're bringing in an inlet and an outlet, there's going to be a minimum distance that they can be away from each other. Um, so it says 8 inches minimum, 20 inches maximum. B, um, A would be the height above, so 12 inches above the roof or snow accumulation level. So obviously you got to get that above, where snow's going to be. Same thing with the ground level. You've got to factor that in. So there's some minimums that you can run that, and there may also be some maximums on that, or maximums from how far apart they can be or how close they can be. So obviously you don't want your exhaust right next to your inlet because then it's just going to be bringing back in the same air that you just tried to send out. So there's got to be some distance between those, and then they've got to be in such a way that, like, if you're coming, most of your furnaces, if they're under the crawl space or in the basement or whatever, if you're running that vent pipe through the wall, as you can see here, you're going to have a foundation, and then above that, you're going to have a header, and that's where your floor joists are going to be attached to. So you've probably got like a 2x12, something like that in there. That's that header, and so you've got that space that a lot of times that's where you're going to run those out. You may not run it out the concrete, you're going to run it out that wood header, and so you can see that it's above that foundation, but it's still maybe not high enough. So you've got to run that up and out so you're above the snow line. And so you're going to refer to manufacturer specs on that, and you can also refer to codes. But manufacturer specs is always best when you're installing. All right. So once again, your vent sizing is going to depend on length of the run, the number of elbows you got to put in it. Another thing about elbows that I'll say is if you can get by with what I'm going to call as a 45, which so an elbow or a 90, is 90 degrees. It's an L, and then you could have a 45, which is actually 120 degrees angle, the fitting itself, or 100 and whatever that comes to. But they call it a 45, and so it looks more like a well, I don't know, it's a wider elbow. That's less restriction that's got to go through. So you can look up in your charts like the equivalent length of an elbow versus the equivalent length of a 45. And so if you could get by with a 45, you can reduce your equivalent length quite a bit. And so you might actually be able to run. There's been times where I would run 45s if I had room, if I was able to. Just makes things run smoother, creates less restriction, lets the water drain back a little easier, and I was able to run 2-inch pipe because of that, because it reduced my total equivalent length to where I could run however many feet of 2-inch pipe that I needed. Co-vented stuff. So the required vent sizing will depend on the length, the height, and total input BTUs. So, like in classroom, we'll kind of look at what we've got in there. Um, all those furnaces may be running off of a 2-inch vent from the top of the furnace, and then it may go to a 3-inch or whatever. But then if I've got another appliance tied into that same flue, I'm trying to, maybe let's say I've got a water heater or a vent, maybe a on-demand water heater. One of those are pretty popular, high efficiency. So you've got PVC coming from it, PVC coming from your furnace, and you're going to co-vent those. So you're going to run them both into um, some sort of main vent. That main vent has to be big enough to handle them both. And so you'll see this a lot in older applications to where you have a furnace, maybe an 80% furnace with, 4-inch, 5-inch metal pipe. And then you've got a water heater that's natural draft that maybe it has, I think it's about 3-inch or 2.5-inch metal coming out of it. And then they'll run up and they'll kind of tie together or wire together or whatever. And then you'll have a main vent that goes out. Something that you need to take into account if you're doing away with, let's say you're doing away with an 80% furnace or an old natural draft furnace, and you're going back with some higher efficiency forced draft or induced draft, whatever. Um, if you're doing away with one part of that, but you're already co-vented to where you've got, let's say you've got a water heater tied in with a gas furnace, and you do away with the gas furnace. Well, now your main vent is oversized. Um, so this is using an example of a chimney, which is a little bit different, but some people you can exhaust those through a chimney if possible. So if you have a chimney available, a lot of older houses have one, and you can vent into that chimney. So something to take into there, but you also have to go by code, make sure that you're doing it right. So um, either way, though, if you're doing away with the furnace, the only appliance left to vent into the chimney or into a common vent is the water heater. So now that common vent is going to be oversized. You're not going to be able to remove the right amount of air like you normally were, or combustion air. So that could cause issues to the water heater, could cause issues to the vent itself, um, maybe cause it to cool down too much and rust out and whatever, and maybe even cause some CO issues back into the house. So you might have to, you'll have to look and see if you do away with an existing furnace, maybe go to a 90 plus, and so you do away with that metal piping. You may have to adjust your common vent to handle the existing water heater or another furnace that may be in the house or whatever. And this may look crazy, but that's actually not that uncommon to see stuff like that. So, All right, so your vent tables, you're actually going to deal with these a lot in your journeyman prep. These are in your code books. There's going to be some vent tables in there that it's going to say like this type of material. So you've got a 100,000 BTU gas furnace that is natural draft. What size you're running? What size pipe can you install to run a total run of so many feet? So you may have to look that up. Or how many feet will a 3-inch pipe, for example, um, what is the maximum height in feet that you can run that, and what is the lateral length or whatever. So you may have to match up some things in a chart. So this is an example of that. This is giving your limitations on different size pipes. So if I've got um, let's just see here. I've got a fan assisted. So this would be a Forester induced draft setup. And let's say I've got 5-inch pipe, 5-inch vent and connector diameter, appliance rating in thousands of BTUs per hour. So let's say I had a 100,000 BTU furnace. Um, I could technically run that in a 4-inch pipe because of the minimum and maximum, but I'd probably like to have 5 in this case, according to this chart, especially depending on length. So depending on how far I'm running it and how high that I've got to get it up in the air. So if I've got to run it through a roof or whatever, that's going to factor in as well. So your height and your lateral length. So just an example of kind of how those work. So there's going to be a lot of those that you're going to have to kind of work through in your code books when you do your journeyman test. So just kind of want you to see those a little bit. But um, venting is something that you got to make sure you're doing it right, because especially when you're doing installs, um, because those can come back to bite you. Obviously, safety issues, both safety of the people, safety of the structure, and durability and proper operation of your equipment. So you don't want a furnace that never works right because it's not vented properly, or you run too small of, you don't want to call back if possible, like I had. So the example I had, where I had to go back, it looked bad on me, and the customer was actually upset, probably more so than he should have been. But he was saying, well, you should have done this in the first place. Why didn't you do that in the first place and have to come back and do this and whatever. And so you don't want that if possible. So always refer to the books, refer to your manuals, make sure that, when you're putting this stuff in or when you're servicing this stuff, that may be a service call that you get, a trouble call, to where, maybe somebody else put it in and they can't get them to come back or whatever, and it'll run for a while and then it kicks off. You may want to look at the installation guide on that to see what the vent specs are. Maybe they undersized it the whole time. Um, you may be the bearer of bad news there, but at least it would help you solve your problem. So, um, just just some good information here, I think. So the book kind of does a pretty good job talking about this. So if you want to look through the other resources that are in this module, I'd recommend that for sure. And then do the quiz associated, and we'll be picking up the next chapter soon. See y'all later.